School, 7th grade Earth and Space Science. I want to welcome you to a very special episode of Student Science Symposium. Guys, outside of going to outer space, today I have the next best thing. I have the game show of scientists here. She is the vacation, the cash, and the car. She's got it all. She has an academic mind, a dynamic personality, and most important, she loves education and she loves teaching kids about space. I'll tell you a little bit about Eylene Pirez. She was born and raised in Cuba, and she pursued her passion for astrophysics at the wonderful school of UCLA, home of the Bruins. She received her bachelor's, master's, and I believe PhD, becoming an absolute true expert across the world in particle accelerator technologies. Her resume is so saturated in a very humble way with scientific endeavors, world travel, and I'm just covering a few of them here. Scientific film advising, work with NASA, spectacular photography, a love of nature, and much, much more. No cap. Nosotros, nuestra escuela y nuestros estudiantes estamos muy agradecidos por su tiempo y su experiencia. Muchas gracias, Eylene Pirez.
I feel like after that introduction, I should just leave it on a high note, right? Thank you for having me.
Sure.
Yeah.
So, we had a chance to communicate before this, and I sent you a list of questions concerning math and science. And your background is very unique in that you were born and raised in Cuba. So I was hoping you could tell the kids what it was like to be born and raised in a different country and then come over here and become a pioneer in your pursuit of astrophysics in California.
Well, I don't have a lot of fun things to say like you about Cuba. Cuba is a communist regime where, I grew up really poor and, it was definitely a struggle and growing up in Cuba was not easy. I grew up during something called Periodo Especial, which is like one of the largest economic crisis in the world, is studied by economists and all of that, just because it's a huge crisis. The only one that's beat us recently was Venezuela, and we know the state of Venezuela at this point. It's not good for the kids to know this. But Cuba is known for its education, but what people don't really understand about the education in Cuba is that it's going through a communist filter. So your doors are immediately shut and you immediately have barriers to overcome. And even though it's free, we're not allowed to learn about world history. We're not allowed to learn about different topics in science. And this is all part of a communist propaganda. And we've seen this happen in many communist countries. And since I was a kid, I knew that that was my biggest adversity. That was a really external force that was working against the things that I wanted for my life. I wanted to live in a place that had, human rights, civil rights, that I had choices, and a place that I could leave, right? In Cuba, you are not allowed to leave your country. So my options for exploring the world and getting to know the world were very, very limited since I was born. And that led me to a lot of illegal migrations. I moved illegally to Colombia in 2000, which was one of the most violent countries at the time. And over there, I experienced a lot of violence and I knew I had to get out. And then I came here illegally in 2001 and I went to prison. And I went to prison when I was 15. And that was life-changing. When many kids were in school, I was in prison. I watched 9/11 sitting in a prison in Florida. And I was there for about a month until I got my citizenship and I got my I got on probation for 5 years. And then I had a chance at citizenship 5 years later. But, all of those things were big adversities, but I was really focused since I was a kid. Then I knew that I had to open doors for myself. And I think that clarity, you can have it since really young. I mean, at 15, I knew exactly that I needed a place where I could have democracy and I could have science and I can travel the world and explore different parts of what it is to be a human being on Earth. So yeah, Cuba was very, very difficult. I love the culture. The best thing of Cuba is the people, not the country, not the politics.
Yeah, unfortunately, reworded that, yes.
we don't deserve our government. You know, I think many people can say that at this point. Unfortunately, sometimes countries become the worst of those countries. But yeah, you know, I still speak Spanish. My entire family has slowly migrated here, all in very similar ways. And, you know, we eat a lot of pork and we love salsa music. And there are a lot of fabulous things about being Cuban, but it was definitely one of the hardest parts of my life. It was one of the biggest adventures of my life. Yeah.
Wow, that's yeah, I'm floored by your stories. I definitely wasn't expecting that at all.
People always talk about the cigars and the old cars, and I was like, yeah, we're gonna disagree on this, but that's okay. You know, when you go to a place as a visitor, it's a very different experience than being part of the system, and I think that that's really important for also kids to know. When you travel, you might not see the entire reality of a country, so it's really good to find ways to really experience what other people are experiencing. Remember that America is only 4% of the population of the world, so what it is to be human is very different where you are and in what location you're in. So, you know, to be a person at this time in America is not the same thing as being a person at this time in Africa or, you know, in different countries. So different perspectives are really rich to have.
So what advice would you give our kids concerning like how they can use their own personal adversity? Because, you know, when we come into a classroom, you don't really know backgrounds or what's been dealt with. So any advice you could give them how to use adversity as far as a platform or a jump start in science or any of their favorite classes?
Yeah, I think since you're a kid, you can start figuring out how to decide for yourself the things that you want. No, I think adversity, it's what you make of it. Everybody deals with different types of adversities. There is adversity that is external forces, and there are adversities that are internal. You know, we all have our inner demons, but there's also outer demons, and being able to kind of figure out what your adversity is and how to best overcome it. There are a lot of positive things that can come from adversity. You know, at 15, being in prison, like I was forced to grow up. I was forced to focus. You know, I was forced to appreciate what came later in life. And when I got to high school, you know, I didn't speak English, just coming from that fairly traumatic experience, it made me really focus on doing something with my life. And I had this chance, and that came from, I took that experience with my adversity and tried to make something good out of it. And I think that in all troubles, there's a lesson to be learned, and making sure that you are mentally healthy and physically healthy after dealing with some of these adversities, and make sure that you can do the best you can afterwards is really crucial. And you can do this since you're very young. And, you know, also reach out. For example, I knew that I had gone through something really big. You know, when you're 15, you can't really tell what happened to you, and it often feels like it happened to somebody else. So, you know, reaching out to mental health and make sure that you can focus on school and finding, you know, healthy outlets for your life and your interest, and, you know, take advantage of the lessons you gain through overcoming these adversities.
Mm. I proposed a question about math and science because I know math and science, or sometimes both, can be very intimidating for seventh graders or when they enter middle school or junior high school. And one question we usually get is, why are we doing math and science? Or there's a difficulty blending how math is so concrete and absolute, but then science is so abstract, and it's getting away from what's the right answer, what's the right answer, what's the right answer, because we're all so used to that.
Yeah.
How should we answer the question, what does math have to do with science? And
well, first of all, I will talk about the social aspect that I've learned from education being here in the US, which is different than when you're in an education system somewhere else. I would like to point that out. So every kind of country deals with different views on what math is. And I think socially, there is this idea that we are fixed learners, and we're not fixed learners. There's a fly around, sorry. We have the ability to grow, and our brain expands, and you are able to learn almost any topic that you really put your mind to. I do think that often in America, as I've noticed, you know, children got taught with the idea of, I am going to go crazy with this. We are taught the idea that, you know, some people are just not cut out for math, or they're not math people, right? And I think that, one, that is absolutely false. Math is for everybody, and math is a universal language. As somebody who came from Spanish, in having to work in a field that's not my native language, I can say that math was single-handedly the most important language that I can possibly speak, because math is the language of the universe, and everything, all the logical ways and all the critical thinking that we can communicate in the world. And
is when the capsule moves from an elliptical orbit to a parabolic orbit. There's no mathematical formula for that. Because we can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
Maybe we've been thinking about this all wrong.
How's that?
Maybe it's not new math at all.
It could be old math. Something that looks at the problem numerically and not theoretically. Math is always dependable.
For you, it is.
Euler's method.
Euler's method.
Yes,
That's ancient.
but it works. It works numerically.
That's it.
Let's type it up.
and our entire civilization is built on math, medicine, technology. I mean, you name it, is every field, the basic language behind it is math. Even art is considered art. You know, math is extremely elegant. more you know math, the more you understand that it's an art and it's a very creative process. It's not just this. And one of the reasons that I think kids are off with it is because they don't realize that there's something really great in making mistakes. I think I've learned the most about, making mistakes. Making a mathematical mistake is what can lead you to true critical thinking and trying new ways to look at something. I think that there's just a lot to learn in mathematics. And, so I do think that there is a problem with the education system in the way that math is taught so tightly to a curriculum, where it narrows down the way you can visualize math, and it narrows down how you view math. It feels very limiting, and I think that if there is one topic that you should walk out of school knowing is math, you're going to learn everything else at some point. Even science, like if you're not that great at science, but math, you can learn science later. If we're exposed to English, for example, all the time. We're exposed to arts all the time. We're exposed to politics in our coins. And, if you go to Europe, some of the bills have even mathematical equations. They have the faces of mathematicians and things like that. And here we don't see that love towards mathematics and science that the world sees everywhere. So I think that there has to be an effort in America to teach that the universal language of the universe is math, and is single-handedly the most important subject there is. And it doesn't mean that you cannot learn it, that I think that there's actually been an experiment on this when they looked at electromagnetic waves in the brain when they're thinking fixed versus growth minded, right? So they have kids who thought, oh, we're definitely not math people. And then they had kids who were like, I think I can learn math. I think anyone can learn math. And they compared both of them, their activity and the brain, and they realized that the ones that had the open mind actually had a lot more neurological activity while solving problems. And this shows that being open to learning can really help you grow those skills. So the more you try, the better you'll do. And then there's also like the other side, like even my husband called me this morning, he called me a dork because I was talking to him. I was like, what am I gonna say about math? And he's like, well, math is not fun. And I was like, I had fun doing math. I sometimes when I'm alone, I like to do a formula, or like to, exercise the brain. And he's
Mary, you knew the problem was incorrect. Why didn't you say anything?
Frank says I'm not supposed to correct older people.
like, you're such a dork. And there's that name calling, or that immediately you see somebody being good at math and somebody is going to probably label you as something that you feel it's negative. And it's not, it's absolutely not. I think that turning off your brain to math since you're young will close so many doors. And you might not be interested in it now, but you might be interested in it later. Like, what about, like, okay, you don't know what you want to be, but maybe in a few years you want to be a doctor, and you have spent all these years not having a good foundation in math. That's a door that you've made that path so much more difficult for yourself. You just close the door for yourself. And this goes in so many ways. So like, I think the second we close the door to learning the universal language behind everything, we have closed so many doors. We have limited ourselves in what we could do. And I think that's a huge adversity that you have to overcome that.
I might take that segment and play it once a week in class. that was really to the point. You're very, very good at explaining things. So.
I think it's because I learned American education older. You know, I'm not a product of American education in so many ways. I came here as a 15-year-old, and I was put in calculus when I got here, and I was with seniors, and I was mocked all the time. One, I didn't speak any Spanish, but I was nailing calculus, right?
Step by step, inch by inch. Calculus was not made to be easy, it already is. Remember the good times we had last summer? Do you remember when things were really jumping good? Yeah. Well, the good times are gone with the wind. It's now the good, the bad, and the ugly.
Oh, come on. A contract? You mean you can't trust us by now?
For those of you making the commitment, you will be preparing yourself for the advanced placement test. Make sure you have one. Make sure it's signed before you come to class tomorrow.
We have to come to school an hour before school, take your class 2 periods, and stay until 5?
Believe it or don't.
Saturdays? You gotta come on Saturdays? And no vacation?
Yep, pass the AP exam and you get college credit.
Big deal. You know, we're seniors. This is our year to slack off.
How about you, Johnny? You'll be able to make it Saturday morning, playing in your band Friday night?
Look, you love scaring us into doing stuff, man, I know. That gets old real fast.
Hey, Kimo, you proud of me? I'm the first dude here. What's calculus?
So it is because I grew up, you know, thinking of math, and I did have a strong mathematical background. And to me, that was the fun part. I was like, I have to write an essay? God, you know, but to me, doing math was the fun part. And you do get mocked. And I think I learned that there was this really strange view of people who are good at math, which I never understood. I was like, okay, well, I want to do something with my life, and I know I'm going to need this. So, and I sometimes, and you know, one of the things I'm extremely competitive, so that was great in math. So my goal was just to beat the best kid in class, or at least to get there. And I know that this is not the best, you know, message to pass on, but if you're struggling in math, like, give yourself, okay, well, this is the kid who has a better grade than me. Try to study with them, you know, try to like find partnerships with people who can push you forward. Because guess what? Just as many people who don't like math, there's a lot of people who do like math and are very quiet about it and are doing much better. And these are people that you can compete with. And I think there is something really rewarding about becoming better at something you don't think you're naturally good at. Like, if you think you're not good at something, becoming better at that is really rewarding. And I think that kids will actually enjoy that if they give it a try.
So how did you take like your education piece with math and science? How did that lead into photography? Like, what was the connection there? And then how does that lead into your work with NASA, Cassini?
You got it backwards.
Okay.
So when I was doing astronomy, remember, like, you know, humans, like the basic logic of humans is to make things in the macroscopic scale that we can talk about, things that are concrete that we can use and have this immediate use, right? And in astronomy, you are talking about something that your senses don't matter. Like, you don't have any experience in space. So therefore, a lot of it is very logical thinking. A lot of it relies on technologies for imaging. And one of the things that I worked in the Cassini spacecraft, I worked in the Cassini spacecraft before I became a photographer, and in other things. I worked for the imaging subsystems at the spacecraft. So my job was to run the cameras aboard the Cassini spacecraft. So I worked in a team where it was just very different type of photography, but it was optics. And it's like, okay, well, we need to learn all these things that I can't be there for. So I found an attachment to capturing images and being able to transmit information through images, and that was a really powerful experience. And it took me a really long time to realize that almost every part of my career led to optics, which was a very interesting, I guess I was just kind of overwhelmed in school and I didn't really have a clear view what I was doing. But after that, I worked, for example, making detector systems for a giant tank of xenon looking for dark matter in Italy. This is the xenon 1-ton experiment. We were looking for a particle that we don't know if it exists, but we're still at it. And I built these things that were practically just making an eyeball for a particle that was just in theory, right? So how do you create an image of something that you don't really understand, right? And that was fascinating to me. I worked later into infrared astronomy, and I worked in telemetry at the Mount Wilson Observatory with Professor, oh my goodness, Charles, I forgot my last name, his last name. He's a Nobel Prize winning. He won the Nobel Prize for the Maser. And he really put me into particle physics because Charles Towns, he put me into the road of particle physics because one of the things that he developed, just as laser and masers are, they're just technologies that allow you to look at a different scale that is not macroscopic, that is not sky. So I went into the extreme, I went from looking at the bigger things we know in the universe to looking at the things in particle level, which is the tiniest things we know in the universe. So it was all connected. It was about all imaging things that we can explain or that we don't understand. And the only scale in which I was not a photographer was the visual scale. So that I was like, I just should get a camera. I mean, I like to explore and learn a lot about the world. So it just came with the territory. I was already a photographer of space and a photographer of particle physics. So it was just the next scale. So.
Do you guys have any questions at the moment before we get into the movie piece?
I actually was going to ask about the Cassini mission.
Mm-hmm.
So, because that's just really interesting that you were involved in that. So what, were you there at Mission Control at all?
Yeah, so I worked in Building 230, a jet propulsion laboratory in Pasadena. And we had Mission Control at the first floor of that. I worked in the third building, really. But often we will go down to Mission Control and do a couple of things there. But mostly we just run them from our computer for our computer lab and stuff like that. We worked in huge teams. It's so difficult to take responsibility for anything we've done because we're such massive teams. Each instrument is 10 people, and then each instrument has to talk to each other, and it's just real team effort, which is fantastic and a really good skill to have. But we also got to enjoy other missions launching from our control room. Like we have Deep Impact, the one that smacked into the asteroid. That was really fun. And then sometimes like at lunch, you go out and watch the guys with the robots trying to simulate like the Mars rovers and trying to get them not stuck. So that was fun. And we did get to do a lot of fun stuff in the control room over there and in the lots. Yeah.
What was your favorite part of the Cassini mission? I mean, my favorite part was the Titan, just the pictures that were sent back from Titan.
Okay.
I don't know, what was your favorite?
Mine was Enceladus.
Okay.
So Enceladus was my first flyby. Awesome. And the first time, so one of the things people don't realize is when we get these photos back are often like tiny pieces and we have to like put them all together based on coordinates and stuff like that. It's a lot of work to actually just even have one of these images. Some of our cameras are like 1 megapixel, which like you have more than that, and but we launched it very early on, so we didn't have those imaging technologies. So we pieced together a lot of photos to create a big one, and we were piecing together Enceladus, and it's like that is something to talk about and keep coming back, and it became for the kids who don't know this, Enceladus is one of the moons around Saturn. And it has something that we call the cat scratches. People ended up coming up with better names, but scientists are terrible at naming things. Like, where you can't see this hole is a black hole. Like we're just very, very simple. So we saw these cat scratches and we realized that there was geological activity, but our first flyby was so quickly. So every couple of months, when we had to do another flyby by the Enceladus moon and take more photos, we started getting geysters and like really revealing interesting features. So Enceladus was something we didn't expect. You know, we knew Titan was interesting, but Enceladus was something that we just were not expecting, and we learned so much from it. So I think that was my favorite part of the Cassini spacecraft. Yeah, so.
All right, sorry. How about what's your company called, and how does that play with, I know you have an involvement with science-based movies, and you work with like high-tech outdoors companies as well, in clothing and apparel and things. But I know our kids would love to hear your perspective on astronomy movies or science fiction, particularly. What's your favorite? What's the most accurate, inaccurate? Who's your favorite actor for astronomy movies?
Well, first of all, I work with anyone who works towards making science for everybody.
Okay.
That is my passion. I think science is for everybody. I think math is for everybody. And I do believe that the more we work on those from different angles, the more well-rounded our citizens would be. It's the same thing with science literacy. I've noticed a huge decline. So I work with different areas that promote scientific, pursuits to make sure that, good messages and is scientifically sound. So I do a lot of advising, and I do work with a lot of brands who do a lot of climate stuff. So climate crisis is a really big interest of mine because, working in a Cassini spacecraft, we look at something like Enceladus, right, or Titan, and almost everything we see, we turn around and be like, what can we compare it from our perspective on Earth? And the more I was looking up, the more I realized that I did not understand our planet nearly as well as I might understand some of these moons. So I understood that what we had here is very unique and worth preserving. So I do work really hard on trying to also explore, Earth and all of those pursuits. I think that's very, very important. And it's going to be really important for the generation, that we're talking to, 7th graders, you're going to unfortunately have to deal with a lot of destruction that's been coming for decades, and it's going to be up to the math and the scientists to figure out a lot of things. And even now we're talking about the pandemic. What are we waiting for? A vaccine. We're relying on those mathematicians. We're relying on those scientists. So it's extremely important. That is the focus these days. And that being said, The Martian is my favorite movie. I think recent movies that we can talk about, I can go into like old Star Trek, but I don't want the kids to hate me. So I think that I really like The Martian. Now,
Now that we can have more complicated conversations, the smart people at NASA have sent me instructions on how to hack the rover so that it can talk.
I do hate a lot of science fiction stuff because I get upset. And I know I'm just being a pain in the butt. But I do just become upset. Like I was watching Gravity and I was just like, I want to walk out of this theater and never talk to anybody about this ever again. And it's just, I do have those impulses of how can they get this wrong? To have Carolyn Porco as a science advisor, She also worked for Cassini, and it's just very upsetting. So yeah, so that's in that sense, that's my those are my favorites.
Yeah, I used the picture from Gravity the other day on a Google form that we put out. So now I feel bad.
Oh no.
Nah, it's fine. It's fine.
So one of the workshops I taught during grad school was I would teach undergrads how to spot mistakes on sci-fi movies, and Gravity was my favorite because they murder George Clooney because they didn't understand gravity. All she needed to do was do a tiny tug and she would have saved George Clooney. I don't know what was pushing him away. They just completely killed him for no reason. And they named the movie Gravity, and I was like, no, you should understand that not understanding gravity would have been a better name for the movie. So that's my beef with Gravity. I'm sorry about it.
Remember, guys, we talked about Ad Astra was the same way. There was a lot of mistakes in that.
Yeah,
like a lot
it's
of the
frustrating.
moon scenes, I was just like, no, this can't be happening like this. So I can understand what you're talking about.
The frustrating part is that they have some of the best advisors on board, but these filmmakers are like, whatever, it looks good, move on, you know?
Right.
So
The whole moon sequence, I was like, and I was telling my wife, I'm like, this is incorrect. This can't happen. This can't happen.
Exactly.
Lunar rover is set for departure to the far side launch complex.
Look at it. The big blue marble. Rover 7, confirming settings. Bearing 290. Alpha, we have what looks like unidentified rovers approaching our position. Possible pirate activity. Alpha, we need backup ASAP. We're being ambushed.
LRV-2 down.
Rory!
I have a puncture.
Roy, you all right?
I'm okay.
It's very frustrating, and I feel like there are so many creative ways to do it correctly and still get it right. I don't know. I feel like there has to be a better going, and I feel bad for all the science advisors who are like, my name is on this.
Right.
I am the science advisor, and these people named the entire movie Gravity, and then they killed their main characters because they didn't understand gravity. So I do see, I would be terribly embarrassed. Yeah.
Eylene, I'm curious, what is the role that a science advisor would play in a movie? I'm sure it probably changes from set to set, but can you walk us through like what a typical day would look like for you and what sort of advice you would give filmmakers?
Yeah, so luckily I've worked mostly as a writer for documentaries, which means that they want me to get it right. Very rarely do I work on anything that's fiction. I would like to, this is something I'm open to, but usually you go through a script and be like, okay, what is the main message here? What are the science? What's the research behind this? What is this gonna look like on screen? And so that kind of stuff is you know, every day looks different. It doesn't have a lot of structure, and it's just, if they take your advice or not, it's up to them. But your job is to try to make it look as more scientifically sound as possible, and then you kind of detach from that all afterwards. So yeah, you're in the pre-production part of, you're involved in pre-production, really.
I could go back to The Martian real quick. I know that it was very scientifically accurate, but do you know how accurate it actually was? Like what percent, Eylene?
No, I'm sure that there were a lot of holes there. At this point, I'm not remembering some of them. I noticed a few of them while I was watching it. I just thought it was far more interesting. There wasn't any like super blatant things where I was just like, I need to get out of here. So I'm pretty sure it has a lot of holes. In all honesty, all science fiction really does is science fiction, right? And in science fiction, you can do things like warp drive. There's a lot of science behind warp drive, right? So like if something is based on a sound theory or a sound study, something can look really unrealistic, but still be good science fiction. And that's very difficult to judge. Another one that I thought was really good was Arrival, but that's less spacey.
Louise. I am Louise.
What is that? Is that a new symbol? I can't tell. Dr. Banks? Hey, what are you doing?
Yeah, fine. They need to see me.
Taking off her hat, Master. Dr. Banks. Is it okay? You're risking contamination.
They need to see me.
Dr. Banks. She's walking towards the screen.
Now that's a proper introduction.
I loved Arrival. That's one of my favorites.
Yeah, that was a great movie.
I've watched that a couple times.
Yeah.
Yeah.
Really
I think
good.
it was actually a mathematician who came up with the language that the aliens spoke in that movie.
Yeah.
So I think there actually is some math or mathematics behind those actual languages, which kind of goes back to what you were saying about how math is involved in everything.
It's a universal language, and being able to express yourself mathematically is really key, even for aliens. Who knew?
Yeah, The Martian was good because they got the time delay correct. Remember, it took time for the message to get back and forth, and they never do that in science fiction.
No, everything is instantaneous. I was like, I wish it was like that. So speaking of the control room, I was in the control room when they landed the Mars rovers. And this was the most excruciating landing. Like people are like, yes, that was a great landing. I was like, are you kidding me? We were there for like half hours. Like, I wonder if they survived. Because this thing was bouncing a mile high and you're just like, all the instruments are in there. Like who puts all of their instruments in a tiny ball and just bounces them a mile high and you have no idea if it's gonna open. So there are all these really great tensions and great moments that happen in the control room. And it's, there's a lot of internships. So kids from early age can visit all of these places and try to get involved. And I definitely recommend it.
I know Netflix just released a series called Away, where I think Hilary Swank is the lead, and that seemed to have sparked a lot of interest with kids asking questions the past couple weeks about going to Mars. So I knew you would be a good source.
The Mars race is, unless we have a really important socioeconomic drive to go to Mars, like war or a race with another country, we could go to Mars tomorrow if people had enough money, if we wanted to put enough money into it and enough effort. But it really, what's missing to go to Mars is the desire to. There isn't a global desire. It's not like the moon race where we were like, we're gonna beat everybody, and we don't have that going on for Mars. But there are 3 missions, all with different perspectives, some from different agencies landing on Mars in March 2021. So that next year should be a very interesting year for Mars.
So if you were to map out one of our 7th grade students and they want to be an astronaut and they want to get themselves academically ready, physically ready, mentally ready to possibly be one of those astronauts that either does the first flyby of Mars or the first landing, what is it going to take? In one of your background videos, you said how you always try and picture the end result, so you can map out and believe everything you're doing is for that end result. So what would they need to start thinking of? How long does it take to get there? What will their bodies have to get used to? What does space legs mean? In that show Away on Netflix, parts of their bodies fell off. I guess is it called atrophy? Like,
yeah.
Is that real? You know what I mean?
I mean, parts of your body can fall off anywhere. Let's just like we lose body parts anywhere. So, physiology, that's not my expertise. If body parts are falling out, they could. I mean, if you get an infection in space, like, I don't know how quickly you can treat it. If something becomes necrotic, you might have to lose it. I'm not really sure what's happening in this show, so I can't speak to
We'll have to
show.
look up who the science advisor was.
That's true.
So I'm not particularly sure what's going on. I haven't heard of a lot of people losing limbs in space,
One of the questions the kids said, they were like, have you ever seen Away? And I said, actually, I did watch it. And they said, well, the guy's part of his foot fell off in space. Can that happen? I'm like, I don't know, but I'll find somebody who can possibly answer the question. So.
I mean, you can lose a foot from anything. So yeah. I think we need more context to the story. I grew up on Star Trek. So that's like my knowledge is, the Trekkies and all of that.
You got to talk a little bit about that, because kids, Ed, obviously, he loves Star Trek. And our kids are getting into it because it's retro.
Yeah, it's great.
Yeah, if you could say a little bit about that. I think
Leonard and Nimoy was a treasure in science fiction. I mean, Star Trek is just, it captures the dreams of going to space so well. For all the people who wanted to dream about like high-tech stuff, warp drive, but it's also just, it historically has captured the imagination of so many scientists, and there is so much science behind this. And this is something I never really realized, like warp drive. There are legitimate scientists who are working really hard in figuring all this stuff out. So what you're seeing on screen at Star Trek is not so far-fetched, is there's actually so many people who have devoted themselves so hard to making all of the scientists. And a lot of these ideas came from, the dream of Star Trek, and having, all the civilizations, and just even the question that Star Trek always brings up is how common can life be in the universe? And like it's a place where you can kind of fantasize. And I think that, Star Trek did a really good job at exposing people to science and also just the dream of going into the universe and what it could be. And I think that that's what's great.
So speaking of like life and maybe it being common, what's your thought, like top number one hopeful place in our solar system, possibility for life? I know you mentioned Enceladus a while ago.
Our solar system.
Yeah.
The search for life is so different than almost anything else we do in other areas of science, because it gives an insight to culture. And it will be it would be so disappointing to like a Copernican view of the universe to not have life anywhere else. So I think that we really want life to be around. Not only that, if we find life in our solar system, it's not saying that there isn't life somewhere else. It's saying that it's abundant enough to be in our solar system in our slice of time, right? We're talking about 14 billion years. Life could have been here before and we're just not near it, right? Like there has to be a slice of time and a slice of space in which life can, be near another life form. I think that is a huge, I don't want to say that is not possible. I do think that there is life out there. I just don't think what we want to see as life exists in our solar system. And I know that's going to be really disappointing. Yesterday, you could even see Mars and you could see the poles. And I was like, you see, that's not a canal. The Martians are not real. And I think that, the Venus news was really interesting. Also, I think released too ahead of its time. But I do think that we do have a chance at finding microbial life that we don't understand it at all. And I think that this is going to require us to think more about processes that we don't have them on Earth. I think to find life outside of Earth, we have to think of life as we don't know it. And I think that that is going to be, so it's hard to speculate because I don't know it. You know, I can sit here all day and tell you that there is life somewhere else and that there should be life somewhere else, or that I'm really excited about this particular place, but the life that we're going to find most likely is a life as we don't know it. So I really have no expectations, and anything I would say would be speculation.
Cool. Yeah. Keep it a surprise.
Yeah.
So
Keep
you
it a
thought
surprise,
the
right?
phosphine thing was too early, the announcement on Venus?
I'm sorry, can you repeat that again?
The gases they found on Venus that you thought they made that phosphine, right? That was too premature as far as like, because they're not sure exactly what could cause that. I know that life can cause that, but we don't know if there's other things that
we
can
call
cause
it a biomarker. So it means that we do associate it with life, but that doesn't mean that there are geological activities that can't make it. So what happens these days is that there is so much misinformation, and the only way to get people to read something is put a big headline on it. And I am seeing that more and more happen that in science, because I guess people just don't want to read science because it's like, we found a phosphine on Venus. No one's going to go read that article. Like, no one's going to go read it. But if we say, hey, we found phosphine on Venus, there might be life there, you know, people will read it. So I think it has become a way to grab attention and kind of redirect it. I don't think is the most effective way to teach something, but I mean, it could be life form. I mean, we know that the surface of Venus is extremely hostile, and the atmosphere it is, but you know, there are, as I said, life doesn't have to be as we know it, and phosphine there does not have to mean that it's life as we know it. It is, I think that is premature. And I'm not even sure if the measurement is done correctly. I mean, we can think back a few years when they were saying that neutrinos travel faster than the speed of light. This was a mistake, but this took a lot of time to correct. And it was, you know, measurements like this are extremely difficult to make and to repeat. So I think they jumped the horse with that headline. But yeah, it's still interesting to think about, hey, is there something that we might not be thinking about in the surface of Venus, maybe, or in the clouds of Venus? Maybe there's some form that can live in the clouds. Who knows? So.
Thank you.
Eylene, if a genie could grant you one answer to any question, space-wise or science-wise, do you have something that you just wish you want to find out more than anything else?
Yes. Dark matter, so we can stop talking about it. You know, every day there is a new theory about dark matter. Is the most fascinating thing. I've worked on it, and I just want to get to the bottom of it. It would tell us so much. You know, we're missing so much of the universe. It's funny how you know, we only have 5% baryonic matter, which is the things that we know, atoms and things like that. We only 5% of the universe is made out of those stuff, and that's all we know. And we don't even know that stuff. We don't even know 5% of the universe, and you know, so much of it is missing. And I think it will help us piece together a lot of gaps in the particle model, and you know, it will give us a better idea of cosmology and things like that. If we can figure out dark matter, it can help string theory and a lot of other cosmological questions that are open. Yeah.
Ed, did you have any questions about like gravity waves or black holes or something that you had mentioned?
Well, no, I had read theories about gravity actually being in multi-dimensional, and that's why it's so much weaker than the other forces. But I was wondering what you thought about that. So they say gravity is so weak comparatively to all the other three forces, and could that be because it's spread over different dimensions?
I'm not familiar with that theory. So I can't answer to that. Gravity is a pretty weak force, but we just found out that there were gravitational waves. So I feel like there's a lot of gaps in our understanding of gravity. So I wouldn't jump the gun saying that it's spread in several. I mean, it is kind of spread in different dimensions. It is in X, Y, and Z at least. So in some ways it's in different coordinate systems, but I'm not sure. All the and I imagine that with that you're thinking something like string theory where we have 12 dimensions and things like that.
Right. That's where I read it. Right.
Yeah, a string theory, even Brian Greene doesn't want to talk about it anymore because we have been expecting to find things that put string theory together and we haven't. So I think at this point everybody's back to I mean, we're always at the drawing board. I don't think anyone's ever away from the drawing board, but I think that how we talk about string theory is going to be restructured, and I think that within the next 10 years we should have better answers or better ideas if string theory is even really a thing.
Right, because we'll never be able to see the actual strings. We won't, the technology doesn't exist or to see the string.
I mean, it doesn't exist. That doesn't mean that somebody out there cannot figure something out, or there are indirect ways to measure a lot of things. So first of all, I think the theory needs to be ironed out. One of the things that, for example, dark matter, the WIMP, which is the one of the theoretical particles that could be responsible for dark matter, something that string theorists are also really looking forward to finding. We feel like we should have found it, especially through the search of the Higgs boson. We should have found that particle, and we haven't. The LHC is working on a lot of efforts to figure that out, and if we can piece that together, we might have some better answers for gravity. But gravity is kind of a mystery, we haven't gone too far from the apple, and like we finally now figure out waves, and then it's a very difficult field.
Right, and it's the only one that doesn't go with the other ones. It's the only force that doesn't interact with the other forces in the same way.
Mm-hmm. Yeah, exactly.
Thanks.
No problem.
I mean, your travels and your adventures, do you have a favorite place in the world that you think about all the time and just have a drive to always go back to? Doesn't matter the day or the time of the year. And then do you have a most inspirational place that you've been? So the favorite and then the most inspirational?
Difficult to think about. I like deserts a lot. So most likely, and by deserts, I also mean glaciers. That's deserts. I think the Southern Patagonian ice field is one of the most beautiful icy deserts you've ever seen in your life. And that's really inspirational, especially when you think of climate change. There's so much science, but also so many people who depend on the hydrocycle and the water sources there, and animals that depend on that. That ecosystem is so fragile and also so important to the oceans, to the wind patterns on the earth. So I think scientifically it's one of the most fascinating places. But I also really liked the Atacama Desert, which is the driest place in our planet. It's actually where you go, there's a valley there that is the closest place to resemble Mars. So when they're looking for life forms that might exist on Mars, what they do is actually go study if there are any microbes or something that we have here on Earth that have been able to survive in those extremes. And that kind of gives you a clue of, oh yeah, maybe we have something that can survive in place without water like that. Obviously Mars is much drier, but maybe back in time, there could have been something that was there. And the Atacama Desert is a place where they study that. It's a high altitude desert. And it's just, it looks like an alien world. It's also where the ALMA Observatory is, which is the observatory who did the measurement on Venus. Yeah, I mean, it's just a fascinating place. They have flamingos that live in this volcanic, there are all these salt flats and all this really intense volcanic waters, pretty much, that have been mixed with all this volcanic minerals. and you can get on that water for like 5 minutes. And then there's all these colonies of flamingos that live there. It's just absolutely fascinating from almost every perspective. And I do think it's also really inspiring because of the history of the culture there. This is where the Inca Empire, used to use this area extensively. So there are all these massive peaks. I'm talking about 6,000 meters plus peaks where you have, they found the world's best preserved mummies up there. And you can learn so much about the history of Capacocha, which is like Incan rituals where they used to do the sacrifices. Like there's just so much to learn there. It's archaeology, it's space, geology. So I think that that's also a really fascinating place to study. Is a very interesting ecosystem, and the sky there is just unbelievable.
I'm going to book my flight for this December and January. Sold.
With COVID, it'll be difficult, but
I know.
But I think that that's definitely a beautiful place to explore, and I think that inspires you to take care of the things we have. You know, definitely a very different life. So,
you guys have any? I went through my list. You hit every question I had written down. So
all right.
Jeremy, Paul, or Sammy, Mike, Ed, do you have any other questions?
I don't have any questions, but I think if students are able to see this, you'll certainly be an inspiration to a lot of our kids. So thank you.
Oh, thank you so much. And I also wanted to tell you guys, I'm currently working on a space video game. So I don't know if you guys work on this, but I'm working with Elite Dangerous and a NASA branch called Frontier, where we're doing the most accurate replica of our galaxy. And you'll be able to go explore these things. And I am the voice in the navigator that tells you what objects are, but you'll be able to go and look at what it looks like, and I'll tell you facts about it. So it's not just a video game, it's a huge educational experience. And this will be coming out probably next year, but you know, if your kids are looking for something to do where they're really interested in space, this will give you probably some of the best graphical representations and facts of space. And you know, if they like video games, you know, I'm not a gamer person. Like the last game I played was Galaga, and I'm just old. But you know, if they're into or that kind of stuff, that is just probably one of the healthiest video games I've heard of. So.
Did they have a name for it yet? Is there a name out?
Yeah, it's called Elite Dangerous.
Oh, okay, gotcha.
Elite Dangerous, and yeah, and we're working on the educational branch. William Shatner is in it. Like I'm just like the baby Brent Spinner from Star Trek is in it. So there's a lot of sci-fi characters there who are coming in and making the show and making it more educational and more fun for people who want to learn about science. So just a little thing.
Well, you said one of your famous quotes was, and I'll wrap this up for the kids. We'll wrap up the recording, but that one of your parting words to people is that your goal is to solidify the bond between the humans and the universe. So, I mean, that's our ultimate goal. When you leave, you know, because you're very big on education with kids and adults. Do you try and leave your body of students? What do you try and leave them with as far as like a quote or an inspiration as they move on to their livelihoods?
Yeah, I there's just so much we can talk about here. Yeah. But I think that if there's something that's enriched my life is figuring out ways to become a lifelong learner. Just because I went through all of this school doesn't mean I'm done learning or I'm an expert at anything or I know anything. You know, when you finish school, you have this commencement, which is to start your life. And this is when you really begin to learn because so much of your curiosity has not been fulfilled in school. And it's up to you as an individual to find all those things that make you happy and make you whole. And I know that sounds very mushy, but it's true. And you know, for me I want to know what my planet is. I want to know what our place as humans is on the universe. And I think you have to find that place here on Earth and understand where you are and understand how people are. And like, as I said, you know, America's only 4% of the people of the world. So there is a lot of views out there, and there's a lot of perspectives, and there's a lot of dreams, and yours is as unique as anybody else's. And I think it's really up to you to find that, to become a lifelong learner, because every day you can learn a little bit more about where you are and what you want. I think that's really rich, and it'll guide you to whatever decisions you want in life, because ultimately that's what will push you forward.
Fantastic. Wow. I'm going to have to end it there. So I would have to say, Abington Junior High School, 7th grade Earthside students, your families, your friends, I bring you Eylene Pirez. Dr. Pirez, thank you for everything, your knowledge, your passion, your character, your inspiration. We sincerely appreciate it. And
yeah, thank you very much.
Thank you.
Thank you so much.
Yeah.
Yeah, I hope the kids like it. You know, when I was in 7th grade, gracias, de nada. When I was in 7th grade, I was in a very different place in my life. And I think that, you know, keeping your opportunities open and listening to different life perspectives can definitely help you find your place. And I hope that they keep, you know, putting up with math. I'm sorry that they don't like the math. We'll keep trying.
Keep trying.
Yeah. So thank you so much for bringing me over.
Yeah,
Sure.
thank you.
All right, kiddos, stay healthy, be well, stay safe, and stay hungry for science. Hasta luego.
Hasta luego.
What is the most astounding fact you can share with us about the universe?
The most astounding fact.
The most astounding fact
is the knowledge that the atoms that comprise life on Earth, the atoms that make up the human body, are traceable to the crucibles that cooked light elements into heavy elements in their core under extreme temperatures and pressures. These stars, the high mass ones among them, went unstable in their later years. They collapsed and then exploded, scattering their enriched guts across the galaxy. Guts made of carbon, nitrogen, oxygen, and all the fundamental ingredients of life itself. These ingredients become part of gas clouds that condense, collapse, form the next generation of solar systems, stars with orbiting planets. And those planets now have the ingredients for life itself. So that when I look up at the night sky, and I know that, yes, we are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us. When I reflect on that fact, I look up. Many people feel small because they're small and the universe is big, but I feel big because my atoms came from those stars. There's a level of connectivity. That's really what you want in life. You want to feel connected. You want to feel relevant. You want to feel like you're a participant in the goings-on of activities and events around you. That's precisely what we are, just by being alive.